So in this reaction, we are going to discuss reactions of carboxylic acids with alcohols. We know the carboxylic acids formula, that is R C double bond O and OH. Actually, it's a general formula for carboxylic acids. In this case, R stands for alkyl group. Now, what is the meaning of this? It's a complete homologous series. We discussed about alkyls earlier when we were talking about alkanes. When we remove one hydrogen from alkane, it becomes alkyl. And what are the members? For example, if I have methane, removing one of the hydrogen, it will become CH3, methyl, right? Okay. Similarly, if I have ethane, then C2H6, removing one hydrogen in that case. So that will again give us a member of alkyl series, which is ethyl. Clear? So ethyl, that is the next member of this alkyl series. So whenever R is written in any general formula, that indicates alkyl group, right? So for example, if I have CH3, C double bond O and OH. So in that case, this CH3 that belongs to alkyl group, methyl, or if I have CH3, CH2, C double bond O and OH, then this belongs to alkyl group, which is ethyl, as you can see, CH3 and CH2, C2H5 overall. So remember the general formula of these carboxylic acids, that is CnH2n plus 1 and COOH. Actually, this part of the general formula that represents alkyl group. Clear? So here, when we name these carboxylic acids, we count all the carbon atoms. So 1 and 2, we always count this functional group carbon as well as the carbons of the alkyl group. So here we have two carbon atoms. So its name will be ethanoic acid. Why I used the word ethane? Because there are two carbon atoms. So here it is propanoic acid. Why? Because you can see there are three carbon atoms. Clear? Okay, so the general formula of these carboxylic acids is R, C double bond O and OH. Similarly, the general formula of alcohols, that is ROH. Here again, it's R, which represents alkyl group. So the members of this homologous series will be this one, CH3OH, which is methanol, right? Similarly, if I have two carbon atoms, then that will be ethanol. So in today's reaction, we are going to use these two compounds, these two types of different compounds like carboxylic acids and alcohols. And it is very important because what happens in this type of reaction? For example, I am going to take this carboxylic acid, which is ethanoic acid. So carboxylic acids, whenever reacts with the alcohols, let me take alcohol uh, like this. I'm going to write it. It's methanol, right? So when they react with each other in specific conditions, I will discuss about these conditions later on, but right now, when carboxylic acids react with alcohol, so what actually happen? Look at this. Uh, Hydrogen from alcohol and OH group from carboxylic acids that will eliminate from these two molecules as a byproduct. Okay, so I am going to underline these portions, sorry, highlighting these two, which is removed. So what we are left with? So we are left with this part of alcohol and this part of carboxylic acids. So after the removal of water, these two they combine with each other and make a product. So CH3, I'm writing this one, CH3 here. Then comes C double bond O, this one, and then comes oxygen of alcohol. I'm going to change the color, and then CH3. Okay, so in this case, we can see two molecules, they linked with each other with the removal of a water molecule. So this type of reaction, when two molecules link with each other with the removal of a small molecule, so these types of reactions are called condensation reaction, right? And that is also the concept which will be used in the type of polymerization later on. So we discussed addition polymerization in case of alkenes. But right now, here, what is condensation reaction? When two molecules link with each other with the removal of a small molecule like water. So this new product has another functional group. So you can see here C double bond O and O that is present in between two alkyl groups, two carbon atoms, you can say. So this new functional group that is known as ester functional group. Is it clear? So remember what is ester functional group? C double bond O and O. If both sides there are chains of carbon atoms, then that is known as ester. So we can say when carboxylic acids react with alcohols, so they give us ester along with the waste product, which is water.
What does
So
condensation reaction mean?
condensation reactions are those reactions in which two molecules they link with each other with the loss of small molecule like water. Those reactions are known as condensation. So you can see here the two parts of the molecules which are encircled in red color, they linked with each other and give us the product, this ester. And for their linkage with each other, there is a loss of water molecule, as you can see, hydrogen from alcohol and OH group from carboxylic acid. That is removed as a byproduct, water. So remember, condensation reactions are those reactions. So you can say here, those reactions in which molecules link with each other, with each other by loss of small
Small
molecule,
particles like water.
yes, like water. Is it clear? So that is condensation reaction, as we can see here in this example. Okay, now ester, that is a new homologous series of compounds. So why I represented ester like this? It's a general formula of ester. R, C double bond O, and O and R. So the functional group of ester is this, which is present between the carbon atoms. This functional group, it's very important point to note that this C double bond O and O, they are present in between two carbon chains, R and R. It will always be in the center of the molecule, will not be at the terminal part, or you can say at the end of the molecule, like you saw in carboxylic acid. C double bond O and OH was at the end of the molecule, isn't it? This carboxyl group. So ester will always be in the chain of the molecule. Now, next step is how can we name it? Now look at this. What I did here, I used different colors to draw this ester structure. So the black color, that is the part of the ester molecule which came from carboxylic acid. And the red color that came from an alcohol. Is it clear? So when I want to write down the name of an ester, so what we have to do, we have to identify the part of the molecule which came from an alcohol. Is it clear? So which part came from alcohol? This part, red in color, right? So I am encircling it. This part, methyl, that came from an alcohol. So what should be its name? That is methyl, right? And the rest of the part, you can see that came from carboxylic acid. Okay, here a tip for the naming of these esters. Look at this. If I have this carboxylic acid, ethanoic acid. We said that when ethanoic acid loses hydrogen, so what is the name of the remaining part? Hmm. After the loss of hydrogen, if it was ethanoic acid, hmm, so after losing hydrogen, this negative part, its name became ethanoate. So oic acid replaced by O8. So you can see this ethanoate structure isn't the same here. So this portion which came from carboxylic acid, that is having two carbon atoms and having a carboxyl group. So its name will be ethanoate. So the name of this ester, by combining these two names, that will be methyl ethanoate. Is it clear? Okay, let's take one more
Yes, sir.
example. Let me give you a very simple hint to name these esters. Look at this. If I have an ester like this, okay, let me make it easier first of all. Okay, that is an ester. How can I say that is an ester? I know that C double bond O and O, that is present in the center of the chain. There are carbon atoms on both sides. You can see of the functional group. So I can simply identify it is an ester. Now I want to name it. So for the naming of an ester, I am giving you a hint. You can break it into two parts, right? For its naming, from where you have to break. Remember, you have to break it between carbon and oxygen. What are the rules? Remember, you so if I say break the bond, carbon oxygen bond, okay? When I say break the carbon oxygen bond, then there are two possibilities. Either you can break this one, that is oxygen carbon bond, or this one, right? That is also a carbon oxygen bond. So if when you want to name an ester, so simple rule, break the carbon and oxygen bond. And the second rule, never break C double bond O and O bond. So it means you will not break from this part of uh, hmm, from this part here, right? According to the rules. So remember these two simple rules for the naming of an ester. So the only one position from where I have to break, so I will get two parts of the molecule. This one and the another, this one. Is it clear? So very easy now. The part without oxygen atoms that came from alcohol, right? And for the naming of alcohol part, what you have to do, you will simply name it as the member of alkyl series. For example, here, how many carbon atoms I have here? So 1 and 2. It means that is ethyl. Is it clear? And the other part of an ester which came from carboxylic acid, so this part which came from carboxylic acid, its name will end at O8. Why? Because this part is having no hydrogen with the oxygen, as you can see here. So its name end at O8. So how many carbons are there? 1, 2, and 3. So if 3 carbon atoms, then its name will be propanoate. So by combining these two names, I can simply name this ester. It will be ethyl propanoate. Is it clear? So remember these two rules to identify the parts. One part which came from alcohol. So without the part which is without oxygen atoms, that came from alcohol. And its name will be like an alkyl members, ethyl, methyl, propyl. And the other part with oxygen atoms that came from carboxylic acids. So its name will end at O8. So let's take one more example. First of all, if I have this compound, is it an ester or is it a carboxylic acid? It's not a carboxylic acid. Why? Because in case of carboxylic acid, sometimes students confuse it with carboxylic acids. Carboxylic acids have OH bonded with C double bond O. They are carboxylic acids. So here C double bond O is not bonded with OH. You can see, and you can see here C double bond O that is present in the center. One side having methyl, another one having hydrogen. So it is an ester. So for the naming, what are the rules? So break the molecule from which part? From where you will break it for its naming? Hmm. Break the carbon oxygen bond. So two options, either from this point or this point. Never break C double bond O and O bond. So you'll not break from here. So breaking here will give me two parts, right? Now, which part came from alcohol? The right one or the left one? Definitely the right one without oxygen atoms. So its name one carbon atom, that is methyl. And the other part, which came from carboxylic acid, that is having one carbon atom. So its name will end at O8. So from methane, it is methanoate. So by combining these two, you can write down the name of the ester, methyl methanoate. Is it clear? Now, after identifying this, I can also identify the formula of the alcohol and acid from which this ester is derived. How? Look at this. If I take this part, which came from carboxylic acid, so C double bond O and O, if I combine, place hydrogen here, then it is carboxylic acid. You can see. And from alcohol, okay, the alcoholic part. So what I have to do, I will place OH with it. So it means that if ester gets water back, the hydrogen goes to the acidic part and OH goes to the alcoholic part. And we get carboxylic acid and alcohols back. It means that this reaction of carboxylic acid with alcohol, you can see it is an alcohol. How they will condense? They will condense by the loss of water. Is it clear? And
Yeah.
again, you can see they will form an ester plus water. So HC double bond O and O and CH3. By the loss of this water, you can see here, it's lost in the form of a byproduct. So it's a reversible reaction. So ester on, and remember, this forward reaction in which ester is formed, that is known as esterification, right? And the reverse, you can see it is the breakdown of ester back into an alcohol and carboxylic acid by the water. So we call it hydrolysis. So esterification, forward reaction in which ester is formed, and the reverse is hydrolysis. So it's a reversible reaction. And the conditions now, as I said, for this reaction, that is taking place in the presence of an acid catalyst, right? Acid is used in this reaction as a catalyst. So let's try one more example and let's try to make the ester formula. If I have this carboxylic acid, name of this carboxylic acid, you can see there it has two carbon atoms, so it is ethanoic acid. When it reacts with an alcohol, let's say I have this alcohol. Now the name of this alcohol, let's name first of all this acid. It has two carbon atoms, so it is ethanoic acid, right? Okay. And this alcohol has one, two, and three. So its name is propanol. So in presence of acid, which is catalyst in this case, so what happens? They will condense by the loss of water. Okay, now what will be the formula of my ester here? That will be CH3, C double bond O, and then came this part of alcohol, which is O, CH2, CH2, and CH3. Now, I want to name this ester. So you can simply name it from the name of the reactants. So the name of this ethanoic acid will become ethanoate, this part that came from ethanoic acid. So its name will be ethanoate. And as this part, propanol, this portion that came from propanol. So its name will be propyl. So when I combine their names, so the name of this ester will be propyl ethanoate. Is it clear? And the byproduct will be
Yes.
water. So these reactions are known as esterification reactions. And remember one thing, all these esters, they have a very unique property. They have fruity smell. Hmm? So these esters, they are also used as a flavors. Clear? So they have fruity smell, and that is very clear distinction or characteristic property of these esters. So whenever carboxylic acids react with alcohols, they form ester along with water. Remember this type of reaction that is known as condensation reaction. Why? Because two molecules, they are linking with each other, the loss of water molecule. So it is known as esterification. And the reverse is the breakdown of ester into acid and carboxylic acid. Alcohol and carboxylic acid. So that is known as hydrolysis. So which type of questions will be asked? They will give the structure of an ester and they will ask to name that ester. So we have practiced different types of structures. So what are the rules for the naming? You just break it, the carbon oxygen bond into two parts, the molecule, and never break C double bond O and O bond. So the only one option left. So the part which is without oxygen, that is the part which came from alcohol. So its name will be just like an alkyl. And the part with oxygen atoms, that will be the part which came from carboxylic acids, and its name will end at O8. Is it clear? So let's see this topic from our book as well. So you can see here, carboxylic acids reacts with alcohols in presence of acid catalyst. So they form ester and water. So how? Look at this, ethanoic acid reacting with the propanol. So you can see the molecules, they are linking with each other with the loss of water molecule. So this is called condensation reaction. And this reaction is reversible. And the catalyst which we are using here, that is sulfuric acid. And the part of the molecule that came from alcohol goes last in the formula. So you can see this part goes at the last of the formula structure. And the first part, that is the part which came from carboxylic acids. Is it clear? So this is about esterification. Got it? So
Yes.